And I'm also really excited about the collaborations that we have going on with universities, because we're doing sort of a number of studies where we want to do our part in showing what is coming out of your washing machine. What does it mean if you have 120 filters across an entire campus? And I mean, I was even shocked by the math in terms of how big of an impact just that would have. Like 100 washing machines on campus, I think it's like more than 5,000 spoons worth of microplastic that we would remove sort of every semester. And that's just one university campus. So you can imagine how quickly that scales.
Welcome to the Lay of the Land podcast, where we are exploring what people are building in Cleveland and throughout Northeast Ohio. I am your host, Jeffrey Stern, and today I had the real pleasure of speaking with Max Pennington, the co-founder and CEO of CLEANR. Max graduated Summa Cum Laude with a degree in chemical engineering from Case Western Reserve University, where he co-developed CLEANR's innovative VORTX filtration technology. Inspired by nature itself, Vortex is capable of removing over 90% of microplastics from washing machine wastewater. Microplastics pollution is a severe and growing environmental crisis, with trillions of tiny plastic particles contaminating ecosystems worldwide, affecting marine life, human health, and the overall environmental balance. Under Max's leadership, CLEANR has garnered significant recognition, including the American Filtration and Separation Society's New Product of the Year Award in 2024, and Max has raised approximately $7 million in funding, positioning it at the forefront of the fight against microplastics pollution. With washing machines identified as the number one source of microplastics pollution, CLEANR's biomimcry filtration solutions are not only important but increasingly requisite. The company is actively partnering with major universities and sustainability organizations, implementing their retrofit filters at campuses nationwide. They are also collaborating closely with leading global washing machine manufacturers to integrate Vortex directly into new appliances, aiming to make sustainability an effortless choice for consumers. I came away from this conversation inspired, as Max exudes real passion for solving this problem and has been incredibly impressive building CLEANR to that end. So please enjoy this awesome conversation with Max Pennington. Lay of the Land is brought to you and is proudly sponsored by Roundstone Insurance. Headquartered in Rocky River, Ohio, Roundstone shares Lay of the Land's same passion for bold ideas and lasting impact from our community's entrepreneurs, innovators, and leaders. Since 2005, Roundstone has pioneered a self-funded captive health insurance model that delivers robust savings for small and medium-sized businesses. They are part of the solution to rising healthcare costs, helping employers offer affordable, high-quality care while driving job creation and economic growth throughout Northeast Ohio. Like many of the voices featured on Lay of the Land, including Roundstone's founder and CEO Mike Schroeder, Roundstone believes entrepreneurship, innovation, and community to be the cornerstones of progress. To learn more about how Roundstone is transforming employee health benefits by empowering employers to save thousands in per employee per year healthcare costs, please visit roundstoneinsurance.com. Roundstone Insurance, built for entrepreneurs, backed by innovation, committed to Cleveland. You have dedicated your early professional life here to tackling this invisible but omnipresent problem that seemingly impacts every single person on Earth at basically all scales, where we don't necessarily understand so much about it, but it seems everyone is increasingly aware of it. And not even preparing actually for our conversation today, I was reading a research article in Nature magazine earlier this week about how airborne microplastics from sources like synthetic clothing are being absorbed by plants and making their way into the leaves and then entering food supply and potentially disrupting human microbiomes and plant growth. And so it's pervasive. This issue of microplastics is everywhere. And I'm curious what initially drew you to this invisible crisis and how it's become, a personal mission of yours to address.
Yeah. So it really all started, I was in an internship at Procter & Gamble, and I was doing life cycle assessments. So trying to look at paper versus plastic packaging and figure out really what was better for the environment. And part of the work I was doing was figuring out, well, what happens if it gets out into the world? What then? And along that train of thought, I started thinking, well, how else is plastic getting out into the world other than just littering? And I basically started researching it and heard this fact that washing machines and our clothing was somehow the number one source of microplastic pollution out into the world. And that was something, I mean, I was still just learning what a microplastic was because this was back in 2021. And there weren't that many people that you could go ask about it. So it sort of became a passion research project of mine. Like, could that really be true that washing machines are the number one source of microplastic pollution? And I found two of my friends, David Dillman and Chip Miller, who co-founded CLEANR with me. And we said, well, if that's true, we should be able to attach some kind of filter to the end of our washing machine and we should see a bunch of stuff. And we basically just took a cup, cut the end of it off, put like a filter mesh on it and ran a load of laundry. And we were shocked at just what came out. We're like, oh my gosh, this is all this gunk and lint, like just like the lint from your dryer filter when you scrape it off and if you made it all wet. And it was just all coming out of the washing machine, being dumped out into the world. And like you said, ending up in our plants, ending up in our water, ultimately ending up back in us. And it was something that just really inspired me. It was something that really inspired them too. And we basically went right to the ThinkBox on Case Western's campus and said, let's start 3D printing, something that can actually attach, because we saw all these problems with the first prototype. And we just haven't stopped since then, just really going after it, learning more and more. And like we were sort of saying before this started, the level of awareness of microplastic pollution has just gone through the roof. We're now, I mean, our investors day after day send us a new article of, hey, did you see this? Did you see that? People on the street are finally sort of aware of what a microplastic is and scared of it. And I think we're hoping to offer a solution where you can take, really a big swing at stopping microplastic pollution at the source.
Did you always have this entrepreneurial inclination, this desire to solve the problems?
I did. I didn't know what I wanted to do, but I decided to come to Case really because of the ThinkBox and what I thought of it. I just thought it was such an awesome opportunity, such a space that like I hadn't seen anything like it. And I was really between a school sort of from my hometown. I'm from Cincinnati, and then coming to Case, and I had a full ride at my school in the hometown. And I sort of decided to take the bet on myself and go up to Case, where I thought, man, that the ThinkBox looks really, really cool. I hope I can figure out something to do with that. And then sort of fell on this problem and started taking it up as a passion project. And I remember we would print prototypes, and for a while we didn't have space at the ThinkBox. We just used it. And we were being like driven crazy because we lived on the north side of campus, and Case is sort of shaped like a banana, and the ThinkBox is on the south side. So we'd have to carry our like prototypes in like bags and everything to like get back to the ThinkBox and keep working on it. And eventually we were just like, this is terrible. We got to ask for some way to store our stuff there. And we finally like got an office up on the 7th floor, and, it's just sort of expanded from that. But it was funny that, the reason we asked was we just got so tired of walking with all the prototypes that we needed something different. But yeah, I always wanted to do something. I just didn't know what it was, and then found this problem that I ended up getting super passionate about, and that keeps growing in sort of size and urgency to solve.
ThinkBox has certainly emerged as a recurring hidden gem of sorts throughout the life of this podcast, but perhaps just give a little overview of what exactly it is and what was so interesting and inspiring to you about it.
Yeah, so the ThinkBox is a 7-story building on Case Western's campus that's really dedicated to, I would say, like hard tech innovation. So there's 3D printers, there's laser cutters, there's a water jet, there's, people to help you use all of the different equipment. It's all open to the public of Cleveland, where you can come in and sort of make whatever passion project you have. And the idea of it is that as you work up the 7 stories of ThinkBox, it's like working through a company. So there's an ideation, sort of floor, there's a prototyping floor, there's more of like an industrialization floor. And then I'm actually on the 6th floor right now, but the 6th floor is like conference room space. So you can actually work, as a company when you have meetings. And then the 7th floor is the incubator space, where we actually have our office and our washing machine lab. But the whole idea is that you can use the building to sort of grow a company and incubate the company as you're getting started.
You describe this initial filter prototype, basically a red Solo cup with some mesh, and it is sufficiently compelling and demonstrative of maybe there's a there. Walk us through kind of the validation of the problem that you conducted at that point to, okay, maybe we have a company here.
Yeah. So it really started pretty much all engineering. We took it on as a project of how do we get something that we can attach to a washing machine that A, captures microplastics, but B, is easy to use and something that the consumer is willing to interact with. And that process, we learned a lot. I mean, we started with what are the conventional ways of filtration that we can try? And there's really two. There's dead end filtration and crossflow filtration. Dead end filtration, you basically like take a mesh and you flow the water at it perpendicularly. And then basically you build up the particulate. The problem in washing machines is the pumps are basically built just to pump up the right level to get it to your drain so that it drains out the washing machine load and you don't have any issues.
Yep.
When you attach a filter to it, it's just not meant for that at all, especially the standard sort of means of filtration. And the hardest thing to filter, interesting, it's actually the cotton portion of the clothing, not the microplastic portion of the clothing. But the other thing, so as you look at clothing, about 60% of it now is synthetic fibers. So your polyesters, your nylons, your polyamides. And then the other 40% is more of the organic. So your cottons, your hemps. But even the cotton and hemp still has additives sprayed on top of it. So you'll get dyes, you'll get flammability retardants, you'll get stiffeners where you have this core, I would say, natural fiber, but everything around it is plastic. So you really don't want those going out into the world either. And I say that because the cotton, while you have to filter it, it basically forms a paper. So it's a lot like the paper making process where you're basically flowing cotton fiber at a mesh and you end up getting this paper that just the washing machine pumps can't pump through. So we learned that pretty quickly. Our early versions of the prototypes, we were sort of making like a prototype a week. And we would attach them to my washing machine in my apartment. And I remember the first one, we like thought we had it. We're like, oh, we're done. Like we can sell this thing, and we attach it to my washing machine. By then we'd ran enough loads that we knew like when it was going to pump in the washing machine cycle. So we attach it and I'm like, all right, I'm just going to go bake some lunch or something. And I'll come back in 15 minutes, set a timer on my phone when it's going to pump out. And we come back in and it's just like the washing machine's not working and like water's dripping down from this early version of the prototype. My roommates are like, are you going to break our washing? Like, they're like, what are you doing? And we learned pretty quickly that the existing technology out there wasn't really going to cut it for this filtration challenge of filtering down to really 50 micron from the washing machine. And that was when we turned to nature. So we started thinking to ourselves once we realized, man, like this is not going to work. We asked what else is out there that filters? And we sort of stumbled upon, well, fish filters. So we started researching it. And there were some studies on like, hey, you can use fish's mouths in this type of way in order to really help with filtration. And we basically said, man, that looks pretty interesting. Like just like a fish is swimming in their gills, they actually generate a vortex to keep their gills from clogging. And we said, well, can we use that in order to filter microplastics from washing machines? So we basically the next day went to the ThinkBox. We printed out this structure that we found in a paper, and it worked. It was the first one that we attached to a washing machine load, and it got through the whole thing. But then there was the whole next set of problems with the existing design where it was horrible to clean. There was no way to like attach the mesh in a way that you could actually access it and use it. The structure that was in the paper was like these concentric rings where it was, different pockets of the fiber that you would have to clean out. So we started saying, well, how do we improve this so that the consumer experience is there? And that was when we ended up basically inventing the Vortex. So now instead of concentric rings, it basically creates a vortex that's continuous and pushes all of the plastic down into what we call the cleaner pod. So that as a user, you really just have to take a canister out of our filter, take the pod, throw it away. And that's the best way to actually handle the microplastics, because we're often asked, well, is that actually okay? Because the microplastics are going into the landfill. Like, what does that mean? And the way we usually answer the question is, we think about it in phases. But the first phase is get it out of our water and get it out of our land. And the best way to do that is to get it into our managed waste systems that have the right liners. They have a layer of sand, a layer of clay, a membrane to make sure that nothing leaches out of it, and then another layer of sand and another layer of clay. So the best way and the best thing to do is actually to throw the microplastics away into the managed waste system. And then over time, we hope to find other uses for it where, ideally you can upcycle the fiber at some point in time. But we really view that as, something that one of our partners could do versus something that we're trying to solve.
To further stage that with maybe some, rudimentary questions. What are microplastics? Why are they bad? Why should we care? I mean, it is obviously, a bit more in the conversations of the day, but why is that the case?
Yeah. So microplastic is defined as a piece of plastic that's smaller than 5 millimeters in size. So you could think like roughly a penny in diameter, all the way down to 1 micron, where a human hair is about 40 microns thick. So 1/40th the size or the width of a human hair. And then anything below that is actually considered a nanoplastic. So a microplastic is just a piece of plastic really small on the micro level. And what you're seeing now as to why you should care is it's ending up in the human body. So there's a recent article, you have like a spoon's worth of microplastics in your brain. Microplastics are being found in, I think, like 77% of blood that's been tested. They're being found in newborn babies. They're being found in the placenta. And there's a number of concerns with that. I mean, the first concern is, well, what's the plastic actually doing to us? And the unfortunate news is there's not great data yet as to what the plastic's doing. But everybody that we've talked to generally agrees, hey, like, I don't want that plastic in my body. And if you wait too long to react and then you find out what it's doing to you, just the core plastic itself, then you're sort of in a situation where it's too late. The other concern, where we already know what the impacts are, is that the microplastics themselves can actually have chemicals attached to them. So PFAS comes to mind, other sort of contaminants come to mind as it goes out into the world that we do know are bad for you, and we know the impacts of them. And basically the microplastics are acting as a carrier of these contaminants into your body. And the studies on the different contaminants that can basically enter your body are pretty well known and out there. So in general, it's very, not good to have this plastic coming into your body with the ability to cross the blood-brain barrier and the ability to likely impact us in a negative way.
I mean, it certainly seems from the perspective of the future, looking back on the present, they will reflect on this kind of problem after you and others, have solved it as quite disastrous.
I think so.
And self-inflicted.
Yeah. Well, I mean, it's always tricky because plastic did have a lot of benefits. And I think, that's often lost too, like food packaging, the hospital industry. There's a lot of things that plastic does well. And there's a lot of things that we're learning that plastic does not do well. So to sort of see and learn and work with industry to figure out what are the solutions where we can't, I mean, there's some things that you just don't want to lose that plastic provides. And then there's some things that plastic is doing to us that we just can't have. So it's going to be really interesting to see where everything shakes out because there are two sides to the story. And I think a lot of people often forget the good parts of plastic. And of course, we're working on the bad parts of it. But it's definitely a two-sided story where we have to find what's right for the world, what's right for us, what's right for industry so that we can all work together to really solve this issue.
We always seem to struggle a bit with the second and third order implications of what seems like really good things, at the onset.
Yeah. And it's shocking where it's coming from because, the number one source is our clothing. Number two is tires. And then the rest is sort of a scattering of different sources like bottles when they get out into the world.
It is surprising. I don't know if it would feel obvious that the number one source is clothing.
I wouldn't think so either. But there's evidence of it around. Like sometimes if you ever take a piece of tape and you look at lint or dust under the microscope, you'd be shocked how much of that dust is actually fiber from your clothing. And then two, I think the thing that really connects with people is everyone knows you have to take the dryer lint filter out and scrape off the lint. So once it connects that, oh, I didn't even realize that was plastic, I get how that could be coming out in the washing machine as well. I think that's when it really starts to ring a bell. But yeah, for me, and for David and for Chip and for really everyone that we start talking to, it's been a first. Like, man, I didn't realize that. So I think there is a big education sort of point that we're working on. And we're glad to see that people are becoming aware of microplastics in general. And we're hopeful to help educate on the sources and what you can do about it.
You had showcased the Vortex mechanism just a moment ago. And I love the origins of it as looking to nature for inspiration. I mean, were you familiar with biomimicry as a concept and, a student of that practice before you intuited that it is a good thing?
Not as much. I mean, I knew like the story of Velcro. I knew the story of a few different concepts that came from nature. But I wasn't like super in tune with biomimicry as much as I am now. I think it was more just we were so stuck that it seemed like the only place to turn. Because we really wanted to focus on how do we use something that's mechanical, and how do we use learnings from what's out there. And as we started piecing it together, basically like the value proposition of biomimicry, where you have creatures that have learned how to do what you're trying to do through evolution over millions of years, it was really powerful. And we said, man, that seems like something we should try. And the results just sort of spoke for themselves. Like as soon as we designed this new prototype, we were able to close a cycle on the washing machine and actually filter everything out. And we just sort of got obsessed with making it better. And now whenever we do have an engineering sort of challenge, biomimicry is definitely top of mind. Like, what can we learn from that's out there that's already solved this issue or solved it in a different way? And there's nothing better than millions of years of evolution of basically testing different things to end up at the ultimate solution.
How would you articulate what CLEANR is?
I would say CLEANR is a filtration technology company where we're focused on removing microplastics, both leaving your home and coming into your home. And our first product is a washing machine filter to go after the number one source of microplastics that are leaving your home. And our end goal with that piece of technology is really to see it integrated into the washing machine so that every newly sold washing machine comes pre-installed, just like a dryer lint filter, with the CLEANR technology. And then as we expand as a company, our goal is to go after other sources of microplastic pollution that are leaving your home, like dryers and dishwashers, but also very importantly, coming into your home. So cleaning your tap water, cleaning, really the whole house water filtration. Maybe one day we'll get to air. But we think the Vortex has a broad number of applications where we'd like to apply it and really go after the microplastic problem in a number of different ways.
I like the framing of it as entering the house and leaving the house.
Thank you.
In the path to get to that kind of vision and destination, there are what I would imagine many stepping stones along the way. And I know in your journey, there's been kind of reorientations of the direction and thinking about the business model as to, whether it makes most sense to sell to a consumer. Does it make more sense to work with the folks who are manufacturing our washing machines to get it kind of embedded within them? Just kind of take us through the evolution of your understanding of the strategy behind go-to-market and where it made most sense for you guys to focus your time and efforts to drive towards the impact that you were working to have, having demonstrated, a workable concept.
Yeah. So I think it really started with where the legislation was back in 2021, 2022, when we were getting off the ground. So France at that moment in time had actually passed a requirement that by 2025, every newly sold washing machine in France was required to have a microplastic filter installed.
That's
And
a good signal.
yeah, so that was basically what got all the OEMs' ears perked up. Like, okay, what are we going to do so that we can still sell washing machines in France? And where's the technology? Where are the startups? What can we do basically internal? And that was really where we were basing the start of the business was let's get the technology ready so that we can license it to the manufacturers to help them meet this sort of French regulatory requirement. And along that path, we started getting introduced to the manufacturers. We started working with them and basically demonstrating our technology, learning what it did, learning what it needed to do better. And we really started this development process. And along the way, we sort of learned two things. One, that the legislation in France wasn't going to be as clear as we originally thought. So the legislation is still passed. It's now 2025. But French washing machines are not required to have microplastic filters in them, basically in effect. And the reason for that is the legislation, there is a bill, but there's no decree that actually enforces the legislation. So what happened was in 2023, they passed this decree with basically these 6 requirements that you had to meet in order to have a microplastic filter on your washing machine. And then 2 weeks later, that decree was removed. So now there's a bill that's sort of unenforceable in France that requires these microplastic filters. But what that did was get the manufacturers interested in it in a way that said, hey, we know that we're going to have to do this in the future. The legislation is going to come. We don't know exactly when, but we generally understand this is a feature we're going to have to add to our product at some point in time. And that actually got Samsung to go out and launch an external microplastics filter for a washing machine. So they're the first filter that's out there that can actually meet the French requirements that were out there for 2 weeks. And that's really when we decided as well that we still want to demonstrate that our technology has the capability to be integrated into the washing machine. And we want to prove that in the consumer marketplace with what now we have our external filters. So we designed basically the full product. We manufactured it. We're still working with the manufacturers with the end goal of integrating the technology into the washing machine. But it's now the first step is show that the Vortex can be out in the world, that people are willing to really pay and help in order to fight the microplastics problem, and that the user experience is solid. And that's why we have the external filters to show that people care, to show that there are people willing to do this, and that the experience and the technology of the Vortex is ready to be integrated into the washing machine, because it is a big endeavor to integrate it into the washing machine. I mean, when you open up a washing machine and you look at the amount of space that's available, it's really little. Particularly if you look at European washing machine models that are even smaller than the US washing machine models. I mean, there's not much space at all. So we actually have prototypes now of our integrated solution in European models that can fit and that can work and that have a really solid user experience. We're getting ready to show that to the manufacturers. We're going to show it to each one of them and really see who wants to work with us to move forward and integrate the technology into the washing machine. But we were really, basically powered by the Vortex to shrink it down so that it can fit inside of this really little space that's available on the inside of the washing machine. But yeah, I mean, I think as we learned and developed and worked with who our end, customer is in mind, we had to pivot and figure out what's the best way to demonstrate the technology, what's the best way to start bringing in revenue to our company, so that we can aim at our ultimate vision. And there's, a quote I always like be stubborn in your vision and flexible in the execution. And I think we've done a good job of doing that, where our vision has stayed the same. We want to see the technology integrated into the washing machine, into every washing machine. And we've had to be flexible in terms of how are we going to get there and how are we going to prove the technology so that the manufacturers feel comfortable in putting it into their machines.
In the spirit, I think, of how we started this conversation with the increasing mind space that this problem is occupying I'd be curious your perspective on whether you feel the driver of adoption for this kind of technology overall is going to be more bottoms up actually, or top down. I mean, a regulatory mandate is a very strong incentive, but if it lacks kind of the teeth to enforce it, then maybe not. But where do you feel the drivers are of what's going to push this forward?
Yeah. I mean, I think it's going to be a bit of both. I think the bottoms up can help the top down in this situation. So, what I mean by that is putting our external filter out into the market and working with people directly to explain how big of an issue this is. I mean, I remember we went to like a farmer's market in Cleveland a couple weeks ago. We just brought a filter. We were sort of testing out like, okay, is our pricing right? Are people willing to buy this? What are the reactions going to be? And we were sort of blown away. I mean, it took long form discussion, like 5-10 minutes per person, but we ended up with like 25 out of 30 people signed up to our email list, like wanting to get information about when the filter came out. Everybody was sort of saying our price point sounded about right. A lot of like, oh, I actually expected it to be a little bit more than that. So that seems like it's in the good spot. So I think people do care. And I think the big challenge for us with the external filter in particular is how do we get the 5 to 10 minutes of education down so that it's scalable, so that we can, educate somebody in 10 seconds or 5 seconds on Instagram or Facebook and actually show that this is a problem. But I think to start, it's all about getting the external filter out into the market, working with our partners. We have some really great NGO partnerships that we've announced and more that we're coming out with. We're starting to work with universities where we're really proud that we put 5 filters on Case Western's campus. We're planning to expand that. But I think getting the external filter out there, showing the manufacturers, hey, look, people are willing to buy this external filter. And we both know that it would be even easier and better for the consumer and really better for everyone if it was integrated into the washing machine. So why don't we focus on a higher end model where presumably, since people are willing to buy our external filter, they would also pay more money so that their washing machine isn't emitting microplastics out into the world. And what often comes to mind is, everybody sort of knows like the energy label sticker. You go to Home Depot, you want to buy a new washing machine. There's like the big yellow sticker for energy label that tells you how much energy it's going to use. We would love the same thing, but for how many microplastics you're going to emit. Like, how good is this washing machine at making sure microplastics aren't going out into the world? And I think once we get some of these proof points out there, it's going to really help the legislative environment, because we've been involved in some of the testimony in the United States where there's 5 states that have actually introduced bills that would require microplastic filters. And one of them is more of a rebate program, which I'll talk about in a second. But we've actually gone to testify. And the main pushback is really, hey, the technology doesn't exist yet, which our response is obviously, hey, we're launching our filter and it does do all of the things that you say it doesn't do. We've actually airshipped filters into the legislative hearings so that they can have a filter in front of them as they're talking about it. So we're doing our best to try to push it along, but there's nothing like true data of, hey, we have 10,000 filters out in the market and consumers are using it and they like it. And all the complaints and concerns that you have, we've actually addressed, because here's our data. And our filters all connect to an app. So we're actually able to monitor how the filters are doing out in the field and use that to help influence the legislatures, influence the washing machine manufacturers, where hopefully we can end up in this winning environment where the manufacturers are able to make some money because they're adding a new feature that does something good for the world. The legislatures might be able to go to like a rebate program. So if you look at New Jersey, for instance, they've actually introduced a bill that would be a rebate. So like Nest thermostats, you could actually get a rebate when you purchase that because it's better at energy usage. We think a similar model in the United States could be really interesting to encourage consumers to purchase, washing machines that have microplastic filters, where the washing machine maker makes money, the government's spending money to help remove microplastics from the environment, and the consumer gets a washing machine that isn't polluting the world. So we think it's going to really start snowballing once we get it out there, in terms of being able to push the different bodies to make sure that we end up at the solution we want.
Maybe this is a silly question, but from the perspective of regulatory pushback or aversion to doing this, Is there big microplastics? Are there proponents of microplastics? Is there anything redeeming at all about microplastics?
No, I mean, you'll find them used in cosmetics that they did have like sort of a benefit for because you could get more like exfoliating properties, but they were actually banned in the Clean Waters Act of 2015. But that was only rinse off cosmetics. So you still have a problem with microplastics are being intentionally added to non rinse off cosmetics. So things that you don't wash off right away. That's really the only area I know that microplastics are being used to like have a perceived consumer benefit, but they're getting banned. And then the other one that's like on the inside of a jewelry box, it's called flock, but they actually use like polyester flock fiber to line the inside of jewelry boxes. But that, I mean, the people that used to work in the flock factories ended up with this terrible lung disease from working in the flock factories because they were inhaling all of this flock fiber that was just synthetic and it was going like right into their lungs and got some disease that they've never sort of seen before. So they've tried, but there's always consequences.
No redeeming qualities.
No.
So selling is always difficult. It doesn't really matter what it is. Selling and educating at the same time is even more difficult. What have you learned about how it resonates out in the wild with people and what it takes to get someone to understand this is a problem and this is a problem we're solving and this is a problem worth paying for something to solve?
Yeah. I think seeing is believing. And I think that for a number of ways. So one, I think seeing the issue of microplastics independent of CLEANR, where I'm not trying to sell anything to you, but you see it naturally sort of come up in the news and say, man, like this looks pretty bad. What is all this about? What am I supposed to do about it? And I think while the news is great and we love that they're pushing the problem, there's not a lot of, well, hey, I'm a concerned consumer. What can I do about it? It's really more just, hey, we found more microplastics in your brain, or we found more of this in your blood. And we really want to help people understand, hey, there are things that you can do that can help protect you in the future, that can help protect the next generation. And I think the other side to seeing is believing is actually showing people what's coming out of the washing machine. So something we've started doing is we'll send out filters and we'll actually ask people to send their pods back to us and we'll take images of it under a microscope and say, hey, look, this is what you captured. This is what you stopped from going out into the world. And the reactions to that have been so authentic. So like, oh my gosh, like I did not realize that that was coming out of my washing machine. Like I don't want to wash without a filter anymore. We actually have like an awesome reaction that like the first one that we put on our Instagram that's like doing really well. And it's just, I think the showing people this is what is coming out of your washing machine where you can see it. That's what makes it real.
Because it is such an invisible problem. I mean, literally without the
It
ability to
is.
see it.
Yeah. No, I mean, it's turning into a buzzword of microplastics, but often it's missing the meat of what is it, where's it coming from, and what can I do about it? And I think that's really where we're trying to step in and help with the education. And then the education drives to, well, I do want to do my part and take microplastics out of the world and out of our water that's ultimately ending up in our bodies. And I think that's really where, people are stepping up and saying, hey, I want to do that.
So you've raised $7 million at the onset of this journey here to, ultimately realize the vision. You're raising additional capital now to help scale. How have you approached and thought about fundraising and what ultimately is the vision that you are painting of in the scenario where CLEANR is able to realize its goals and ambitions? What does that world look like, and what is the role that CLEANR is playing within it?
Yeah. So I think from the fundraising side, I mean, we've really done all angel investment to date. So we've have a really great group of investors. We're at about 50 investors to date, who a lot of them are friends and family, some strategics, and all of them have been more than happy to help us sort of along our journey. Some of them have helped with warehousing, some have helped with connections, some have helped with marketing strategy, our IoT strategy, and everybody's really sort of come together and decided, hey, this is something that we're passionate about. I remember one of our investors had like a heart sort of surgery and actually found microplastics in their heart. The doctor told him, and they didn't know if that's what caused it or not, but that got him so passionate that he wanted to do something about it. And I mean, terrifying anecdotal story that, microplastics are being found in your heart during a surgery. So we've had a number of investors that have actually had experiences with microplastics who said, hey, I want to help. And here's how I want to help. I want to work with CLEANR. And they've been tremendous sort of along the way in supporting us in our journey. And in terms of our ultimate vision, really with the Vortex, I mean, I think there's a number of verticals that we want to go into. I think the first one is washing machines, because that's what we started with. That was the number one source of microplastic pollution that we were going after. But I think as we were working to solve that problem, we had to invent a technology that had broader applications in the Vortex. So we actually put the Vortex into the American Filtration and Separation Society's conference, and we won New Product of the Year last year. And we've had sort of a number of incoming requests about, hey, can we use the Vortex for this? Or can we use the Vortex for this machine over here that has, nothing to do with washing machines? And I think the other market potential of the Vortex wants us to keep growing the company into those adjacent markets where we can have, an impact because we have technology with the value proposition, but also with the meaning, where we're helping reduce plastic, production, or we're helping take microplastics out of something different. So we'd really like to see us be an answer to the microplastic pollution problem broader than washing machines. Washing machines are our start and they're our focus, and we're really laser focused on that right now. But 5 to 10 years from now, we'd love to be on the sink, and we'd love to be on the dryer, and we'd love to be filtering out, microplastics from beverages. And I think that it needs to be this sort of industry-wide and multiple industry solution to tackle the microplastic problem. And we'd like to apply the Vortex across industry in order to do that.
I had recently finished reading a biography of, an autobiography rather, of James Dyson.
I'm reading that right now.
And there's a lot of interesting parallels that I kind of see in your journey and how you're approaching it. And I mean, obviously the physical nature of what it is that you're trying to transform. But I think one of the real ironies is Dyson ultimately went through over 4,000 iterations to get to the design that worked. It's quite remarkable that you guys got it out of the box. I mean, that's incredible.
Thank you. Yeah, I mean, we were doing one of the girls that we hired, she went to film school in LA and then came on to do our marketing. And we were doing like this video where we lined up all of the prototypes that we had ever made, because we save them in these like boxes, and it filled up like 4 or 5 tables, like really long 6-foot tables of different iterations. And they were like step change iterations, not even like, hey, we tweaked this rib or we, moved this angle. It was like looked substantially different iterations. And that was a sort of like an eye-opening, inspiring moment for us as the founders to look at, man, like look at all of these prototypes that we had forgotten about, that we had to go through to get to where we are. And there were a couple of moments too, like we were working with one of the manufacturers, and we had to test with pet hair. And in order to pass sort of the pet hair test, we had to go through like 20 to 30 iterations of all of the different like parts of our filter in order to make sure that it worked with pet hair. So, I mean, all of the parts of the design we've had to tweak thousands and hundreds of times on each individual component to end up at the filter that we have now. And I think the process and learning that process, like where you find something that it can't do, and then you get to watch the iteration process of learning how to make it so it can do that thing, is really just been addicting to us, where it's like you get to print something down on the 3rd floor of the ThinkBox, and 5 hours after you came up with this idea, you have it and you're already testing it. And I think the speed at which we can work with all of the equipment that is available here in Cleveland at the ThinkBox, for free, has just been a huge sort of driver of being able to move as fast as we have.
It is a real through line, this iterative process of improvement and a deep conviction that this is the way it should be. Why is this the way that it is?
Yeah. Yeah. And I mean, we really haven't ran into anything that we wanted to make that we haven't been able to. Like, and I think that's really been quite neat for us because we have like a European side of our lab, we have an American side of our lab where we have different washing machine models. And we really just had to like build the whole thing out ourselves and learn like, how do you build a washing machine lab? How do you like sense all of the things that you need to sense? How do you integrate the electronics and have it like, connect to Wi-Fi, and just learning that process and adding it into the design without breaking something else over here just takes a lot of iterations. And anytime that you can shrink down how long it takes to do that iteration just makes you go that much faster.
How then do you think about differentiation and protection? Is there a fear that the larger OEMs, may just be able to develop their own technology and integrate it internally? How are you thinking about that kind of dynamic?
Yeah. Well, I think so. On the Vortex, we work with a really well-renowned IP firm that, we have a very solid set of claims that we think are going to be commercially viable and defensible. And we think we're going to end up with a broad set of them. It's still pending, so we'll see how it all shapes out. But we're doing the right filings and we're working with the right people to make sure we get as broad coverage as we possibly can. And then in terms of the differentiation with the manufacturers, I think that's another point where the data and the learnings from actually being in the field and getting the next round of iteration where, it's all like technology readiness level. And to get to the next technology readiness level, you have to have the technology in the field, and you have to learn how are consumers actually going to use it and how can we improve on what consumers are using the technology for. And right now there's no filter that's in the market in the United States that is able to meet the French legislative requirements. And I think that data is going to help us stay, sort of ahead of where the manufacturers are. And we want to work with the manufacturers and actually integrate with them, because we've had to become, in some ways, filtration experts, and specifically washing machine filtration experts, to get to where we are. And in general, I think the washing machine manufacturers can utilize us so that they don't have to go through the same process that we had to go through in order to basically put a filter on the inside of the washing machine when we have one that's already out in the market, that's set up well. So I think that's one side of it. And then the other side is, because of the Vortex and because of the natural inspiration, we're just able to make our technology fit into a smaller space. And it's a big space constraint problem. In order to come up with the technology that fits in the washing machine, that doesn't need a ton of space, and that actually has a consumer experience that you can use, it's a pretty tough challenge. So I think the Vortex has really helped us be able to get to the prototype where we are, and nature inspiration of the design. And we've protected that through IP.
What are you most excited about looking forward?
Yeah, I'm super excited to launch the filters. So we're actually doing an early bird sale starting on Earth Day, and then that's going to end up being sales that are available on Ocean's Day, which Earth Day is April 22nd, Ocean's Day is June 8th. So it's really coming up here really quick. And I'm just really excited to hear what consumers have to say, what they say when they see their pods, and then working with the manufacturers to help actually integrate the technology into the washing machine and see the next phase of it. It's been really cool where, over time we were very deep in engineering, very deep in working with the manufacturers. Now we're deep in go to market. And I really get excited when we're enter like a new phase of the company where I sort of have to like shift my hat into doing something new and different to drive the company forward. And I'm really excited for this go to market phase. And actually seeing people's reactions to the filter being installed, in their homes, and being able to do their part in fighting the microplastic problem. And I'm also really excited about the collaborations that we have going on with universities, because we're doing sort of a number of studies where we want to do our part in showing what is coming out of your washing machine. What does it mean if you have, 120 filters across an entire campus? And I mean, I was even shocked by the math in terms of how big of an impact just that would have. Like 100 washing machines on campus, I think it's like more than 5,000 spoons worth of microplastic that we would remove sort of every semester. And that's just one university campus. So you can imagine how quickly that scales in terms of the microplastics that are coming out. We're super excited to have 3 universities entering into our pilot program. We want to keep expanding that. We really want to work with the universities because they're the thought leaders in the space. They're the ones that are saying, hey, here's what microplastics are doing to you, and here's what you can do about it. And we want to, play our part in that research and help with the microplastic filtration and show that the Vortex is really capable of removing microplastics in a way that's meaningful.
5,000 spoons is a powerful visualization.
Yeah.
So
It's
a
a
little
lot.
terrifying.
Yeah. And we're adding a feature to our app too. Like when you buy a filter and you connect it to your app, it's actually going to tell you like how many credit cards worth of microplastic we estimate you've removed, how many spoons. We're going to try to make sure it's all like shareable. So you can be like, hey, my cleaner has removed
Right.
100 spoons
Which
worth of
form of
microplastics.
plastic product is the
Yeah.
most visceral, uncomfortable
Yeah.
framing
Credit
of it?
card comes up a lot just because there's hey, you eat a credit card's worth of microplastics every week, which that's gotten a little bit of pushback on, but you definitely are eating a lot of microplastics a week. I think people are just doubting if it's a full credit card's worth of them or not.
Perhaps the greatest switching of hats that you may have worn is this transition from college student to CEO. And I'm curious, in the entrepreneurial journey that you've been on here, what sticks out to you with regards to what you've learned about leadership and management and more on that side of the equation?
Yeah. Well, I think it started so right before I graduated, I took Michael Goldberg's entrepreneurship course where you go out to Silicon Valley as part of what is now a fellowship. So it's the Beal Snyder Fellowship. I was in sort of the first cohort of that, and we actually got to go out and speak with other really case alumni that were out in Silicon Valley that had started their own companies, and the learnings that they had along the way, the books that they read, the things that they did, the ways that they sort of grew. And then I think the other side of it is just the people, the investors that we have, our chairman of the board, Terry Moore, just being tremendous coaches to me. Because I mean, yeah, you start and all I had done was, I was an intern at Procter and Gamble, and I had this idea that we wanted to go with. But how does that translate into then needing to be able to run a business and look at the cash flow forecast, look at where do we need to strategically go, how do we need to pivot, how do we need to work with the washing machine manufacturers and protect our IP. That's all been through coaching of our investors, our board, and really just trying to be a sponge and soak it all in. And I think finally I've gotten to the point where I've soaked it in, and now I'm like forming my own opinions about the best way to do it. Like I think a lot of it was sort of transformative and, hey, here's the best practice that I've learned. And I think I've finally gotten to the point where I get to add my own sort of shift to it. Like, hey, I like what you did there, but I actually want to do it with this twist on it because I think that would be better based on what I've seen over the last 2 years of sort of putting this together. So that's another really fun part of where we are is I've gotten this crash course of sort of business 101, taking CLEANR sort of off the ground to now where we are. And we have the whole next set of journeys where I'm going to have to grow again and learn again. But it's been really exciting and fun just from a learning perspective of being able to start almost at zero in terms of business and go into, how are we going to run a company and drive a new idea. And that's something that just gets me going. Like, I love when you can come up with a concept and you can like just make it happen. Like when you have an idea and then you're able to like in a matter of days or weeks, like end up sort of shifting the business because you had this idea and then you see the positive impacts of it. Like I just love the ability to do that. And that was something I was always disappointed with at my experience in the intern level at bigger companies is just the levels of red tape, the amount of sort of time it takes to get something that you think and that you're really passionate about sort of across the line versus in the startup world, it's just so much faster where you're able to really drive a new idea, get everybody bought in and go do it.
What have been the more trying and difficult parts of this process for you?
I think one of the hardest ones was when we thought we were ready to launch the mass production tooling of the filter, and we had sent one of our prototypes to one of the manufacturers, and it basically, we were testing, we knew it needed to work with hair. We sort of were able to come to that conclusion. It wasn't too hard, but we were using wig hair because we just could buy it on Amazon. It was pretty easy. It would come in. And it turned out that there's a difference between wig hair and actual pet hair, because wig hair, it was more of like a plastic and it was hydrophobic, versus pet hair was actually hydrophilic. So it absorbed the water, which basically made it saturate and stick to everything. And I mean, it just broke. Like it was not ready to go, which was a total blessing that we had that test done. But I remember like we had to redesign everything and we had to do it as fast as we possibly could. And those were long nights, a lot of stress trying to figure out like, how are we going to make sure that it works with pet hair? And I remember some of the people in the lab that worked for me, they said, like, Max, if you keep bringing us this wet pet hair that smells terrible, like we're not going to do this test. Like, this is awful. Like, we're not doing that. So I had to like go around Cleveland to try to find a pet hair supplier that washed the animal, dried the animal, and then shaved the animal to get the pet hair to run this test. And I mean, I had to like call different pet hair shops and say, hey, can we have some of your pet hair, please? And explain to them why on earth we needed that. But that was probably one of the hardest moments to get through. And, you know, we got through it. It works great with pets now. And yeah, that was one of sort of the pivotal moments where we knew we had to just really put our heads down and figure it out.
Are there things that you wish you had known about what it would take when you were starting it that now you understand?
Absolutely. I mean, I've heard a number of founders say, like, man, if you knew how hard it was going to be, you might not have gotten started in the first place. But I actually liked the naive perspective that we had, that it was going to be easy and that, you know, light was, you know, just a couple of feet away, because it just gave you something to just keep going. And I like the idea that, you know, we're always close and we can do it. And, you know, why not us? And I think that naive sort of mindset that we had was actually a blessing, where it just kept us going. Because if we knew how many hurdles that we were going to run into, how many things we had to fix, it could have been overwhelming. But instead, it was just sort of, hey, we're going to take it one day at a time, keep working on improving it and get it to where it needs to be. And I think I like that mindset better. That being said, I mean, there's different design changes that I would have made earlier had we had more insight. But in terms of like the overall mindset, I would not want to know like the number of things we would have to do before starting.
Bit of a thought experiment here, but the thousands of spoons has
Mm-hmm.
me thinking, if resources were no constraint, what is it, a radical experiment you could run that would be particularly interesting for you to see what happens with it, with regards to like accelerating the solving of this problem?
Hmm. I mean, I would say something that would be really interesting is if you could have all of the washing machine wastewater, just the washing machine wastewater, go to like a centralized facility and try to make a ginormous vortex to really filter all the washing machine wastewater from just this facility. That would be something that I think you would see immediately how much is coming out of the washing machine, and you'd get this ginormous ball of microplastics from, you know, all of the washing machines in Cleveland. But that's part of the problem too, is like we always are asked, well, why can't you just solve it at the wastewater treatment plant level? And the problem is, as soon as the washing machine wastewater combines with all the other water, you know, you get the sink water, the toilet water, the shower water, and it all gets combined. So now you have a big set of diluted microplastics. They start breaking down from microplastics into nanoplastics basically as soon as they leave your washing machine. And that's the other thing we haven't touched on yet, but it's really important to capture microplastics at the source before they break down into something that you just can't capture at the nano level, at least with the available technology today. And once it gets to the wastewater treatment plant, there's not really filtration there, because if you have a filter and it backs up, the impact of that is the streets flood, which is just not really possible.
Yeah.
And the other side, so basically what happens is the microplastics settle down into the settlement tanks and they get sludge. The sludge is, for the most part, used as fertilizer on our farm fields. So the microplastics that did settle into the sludge then go right onto our farms, which can go into our plants, get eaten by the animals, and everything else, which is like 30% of the microplastics, just go right out into the water. So that's why when you asked what I would do, I said only the washing machine wastewater goes to one plant so that it doesn't get like super diluted by everything else. But yeah, I think that would be really eye-opening to everybody to see what comes out of just the washing machines and to show how big of a ball of microplastics we would catch.
Yeah, it's really fascinating, really. Well, with that all being said, are there particular parts of your journey or anything else in reflection that you would want to expand upon or introduce as something that is important we haven't discussed yet?
I would just say the importance to us of Cleveland. We really work a lot in Cleveland. We love Cleveland. We love the ThinkBox. We work with the Cleveland Water Alliance. We're right on Lake Erie. Lake Erie has a really high level of microplastic pollution. There's actually just a study done by the International Joint Commission that showed like the fish from Lake Erie had some of the highest level of microplastic pollution in the world. So I think my final point would be, we really think that Cleveland can be the ground zero in the fight against microplastic pollution. And the support and all of the, sort of incoming notes that we've gotten from Clevelanders and people that like that this is built out of the land. It really keeps us going. It keeps us inspired. It's something that's really awesome to see. On the back of the Plain Dealer article, we actually had like 30 or 40 like emails come in to our website saying, hey, when can we get this filter? We love that it's made in the land. Somebody actually said, like, I want to buy it for all my friends and family for Christmas. And those types of notes, that type of support from Cleveland and just the ability to protect the Great Lakes really just keep us going and keep us believing that we can be the ground zero in the fight against microplastics.
How optimistic are you about solving this problem?
I think there's a lot of work to do, but I think it's work that can be done. And I think the important part is starting. Like, we have to get the ball rolling. And I think that's what we're doing with our external filter cleaner for washing machines. And I think momentum builds momentum. And once the momentum gets going and, the awareness is coming, once the solutions start coming out that people understand, I think that the momentum is going to get the ball rolling to really, take a big cut at microplastic pollution. And I am super excited to get that ball rolling, and I'm hopeful that it rolls as fast as I think it will.
Yeah.
But I'm sure there's going to be hurdles along the way. But I'm definitely hopeful and cautiously optimistic that it's going to scale in the way that we want it to, as fast as we want it to stop microplastic pollution. Like I said, both leaving your home and coming into your home.
And you're about as well positioned as you can be to address that ingress, egress, filtration kind of framing of it. Very exciting stuff.
Yeah.
It's really cool.
Thank you. Yeah, no, we're super excited, and it should be a lot of fun when it hits the market here in a number of weeks.
Right on. Well, I'll hit you then with our traditional closing question, which is for a hidden gem in Cleveland.
Yeah, I was thinking about this. I really love Larder, the deli. I go there all the time. Larder's up there for me, and then also I love sushi. So Genko, I think, would be another one for me, where I love both of those places. I think they're awesome and unique to Cleveland. You go in there and there's just like such a unique energy in both of them, and I think both of those have just been like a constant spot that I like to go to.
Excellent gems. Well, Max, I just want to thank you for coming on, sharing more about your story and the work that you're doing, and wishing you as much success in pushing this momentum to solve this important and increasingly visible problem.
Yeah, thank you. Thank you for having me.
If folks had anything they wanted to follow up with you about, where would you point them?
I think either my LinkedIn or on our Instagram, which is cleaner.life, and then we'll get back pretty quick. We also have on our website, pre-orders are available now. So if anyone's interested in purchasing a filter, they're available on our website. And we have a form on the bottom of the website that will go to our team as well that we'll respond to.
Amazing. Thank you again, Max.
Thank you.
That's all for this week. Thank you for listening. We'd love to hear your thoughts on today's show. So if you have any feedback, please send over an email to jeffrey@layoftheland.fm or find us on Twitter @podlayoftheland or @sternhefe, JEFE. If you or someone you know would make a good guest for our show, please reach out as well and let us know. And if you enjoy the podcast, please subscribe and leave a review on iTunes or on your preferred podcast player. Your support goes a long way to help us spread the word and continue to bring the Cleveland founders and builders we love having on the show. We'll be back here next week at the same time to map more of the land. The Lay of the Land podcast was developed in collaboration with the Up Company LLC. At the time of this recording, unless otherwise indicated, we do not own equity or other financial interests in the company which appear on this show. All opinions expressed by podcast participants are solely their own and do not reflect the opinions of any entity which employs us. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. Thank you for listening, and we'll talk to you next week.